Hello everyone, in the video I'm going to show how to extract rotation around one axis for the object. In our case it will be camera. So in camera we have in motion build rotation exposed at the early angles, and we can't really use axis Y from early angles because the rotation could disrupt, so that it's not possible to do it when we have a full freedom of 3 rotations for the camera. So if we want to extract a stable rotation about the global y-axis, we can do it in different ways. And in this particular case, I'm going to show a usage of the sphere chords box in relation constraint, which is part of openmobu plugins. So yeah, let me show what I will do with this. So first of all, we need a camera that we want to extract rotation from. And the idea of sphere chord is actually we have it in relation constraint. If we create a relation constraint, and then we have the Snail 3D, and we have the sphere chords relation box. So what it needs as the input, it needs the position of our raycast to extract the sphere chords. And sphere chords is actually the U and V chords from the sphere. So if we align sphere and keep it following the camera with XYZ, only translation, no rotation. So that means that we cast the ray of the current direction from the camera into the target, we cast it into the sphere, and we return back our UV chords on the sphere. And the U chord will be actually rotation around the up y-axis in world space. So let's try to do this. We need actually the geometry polysphere to be placed and follow the camera. So this polysphere will be used as the extraction point, as the extraction service with the UV chords to receive our value. So we put it here as the sender, and we have here, because we will use geometry, we can connect any of the channels into the TM node, which is the transform node. We do it like this. And then we also need from our side to have the camera as the target, as the ray origin, and then we need our target as the target of a ray. So that will be direction of ray. So this will be our origin, all in global space. And the U coordinate, it will be our actually rotation. So now we need a node to show this up. So I'm going to put some null node in here in the position of the camera. It also could be following in translation the camera. So let's make it bigger to be really visible in space. So it looks like this. So now the U coordinate is the coordinate around the sphere, but it's the U coordinate is in range between 0 and 1. And in motion builder rotation is in range of degrees, so the full circle will be 360. So we need to convert the value that we have into 360. So we put this as the receiver, and then we want to have a conversion. So we have the number, and we want to multiply the value that we have from U into multiply with a 360 to convert to degrees, and then connect it to the rotation. And in our case, it has to be rotation by y-axis in global coordinates. Yeah, so let's show the values. We have a value now, and let's see what happens. So we see that it's rotating, but in opposite direction. So what we have to do now is to have some subtraction. Actually, to have the opposite direction of rotation, we need to subtract from 360, we need to subtract the result that we have and connect it back to the y-axis. So if we connect it like this, then we see that it's all working, and no matter what is the orientation around other axes we have on the camera, it will always show us the correct rotation around one upper y-axis in the world space. So this test scene I'm going to upload on the GitHub repository as well, and hope the video is useful for you. So it's kind of tip and tricks for region in Motion Builder using relation constraint and some fancy nodes. Thanks for watching. See you. Bye.